Oh, it started. Perfect. Nice. Yeah, the Greek letter lambda. So we want to find out if these are concurrent. In other words, do they cross? And if so, find the position vector. So I'll let you get started on it, see if you can set it up. One thing I'd suggest while you're setting things up is these stages are quite mundane. You're just rewriting part of the question, then you're rewriting it again. And the tendency while you're doing mundane tasks in math is to change numbers for no reason, to add negatives when they don't exist. Because you're like, this is an easy part. I don't have to think about it. And you just do it. I noticed I did it. I changed this 2 to a 4 because I was already thinking about that 4. I don't know. And then you got to check. So just take the time to check while you're doing it, because it's a lot more frustrating to check after you start getting numbers like 553 over 135. And you're like, should I be getting these fractions? I'm going to cancel out the lambdas by multiplying that second one by -2. You can choose whichever works best for you. You can use, yeah. It was a lambda. I just wrote it upside down. So add them up. Negative. You get -5 for t. Now, if we wanted to be really careful, we will plug that into one of our equations to see if we can find out what lambda would be. So if t is -5, you would have 18 plus a -15 is equal to, I should have chosen the other equation, -5 plus 2 lambda. 3, 8 equals 2 lambda. Lambda equal 4. And I can go back down. What I did here for this part is once I figured out t was -5, and I plugged back into this equation.
Oh, you just kept writing down the -5 times 3.
That's right. -5 times 3 gives me -15. So now I know what both t and lambda is. We want to find out. And if you can solve for t and lambda, barring any mistakes, you will have found out, yes, they are concurrent. And we need to find the position vector of their point of intersection. What does lambda mean? It's just a Greek letter like pi. But there's no English word that you can make a joke. It's what you say to a person when they don't recognize a baby sheep. That's a lambda. That was pretty bad. And that's going to be recorded. So if you missed the joke, you can watch it later. Okay, so if we plug in 4 for lambda, you're going to have negative 5 plus 4 times 2 is 8. You're going to get the point 3, and when you got 4 plus 4 times 1, you're going to get 3 comma 8. That's what happens when I plug it into R2. If I plug it into R1, I'd be plugging in negative 5 for t, and 18 plus 3 times negative 5 gives me 3, and negative 2 plus 10 will give me 8. So it's not bad to check both, because then you'll know, yes, I didn't make a mistake. Because often a person will make a silly mistake in their resolution, and then if they use the wrong value, you're going to lose a lot of marks, because you got a wrong value of lambda and then a wrong answer. And these questions that are 5 or 7 marks, there are a lot of marks for these questions. Because you get marks for setting up your parametric equations. Sometimes 1 mark for this one, 1 mark for this one. 1 mark for setting up your system. So we're at 3 marks already. 1 mark for solving for t, 1 mark for solving for lambda, and 1 mark for solving for the actual point. And it's a 6-mark question that isn't that involved. So you want to make sure you get all 5 or 6 marks from that question. We're going to skip the next one and do the 3-dimensional one.